Hello, everyone. Um, Today I will talk about monitoring a JHipster microservice architecture. But first I want to ask you uh, who in this room has already used or tried out JHipster before? Yeah. So don't worry if you haven't. This session will show how to monitor microservice architecture using JHipster, but the stuff we talk about could be applied to other stacks as well. It's fully based on those two open source projects, ELK and Zipkin, and you will be able to follow along. But first, let me introduce myself. So I'm Pierre Besson. I work as a full stack developer at Ipon Technology, which is based in Paris. I'm enthusiastic about monitoring, but in no way I am a monitoring expert. So obviously take what I say with a grain of salt. But I think as a developer, I have tried to implement monitoring best practices and actually monitor my stack, and it has been a very valuable experience for me. I'm also part of the JHipster project as a core team member with Julien Dubois, which works in the same company as I do. So if you want to reach out to Ipon, we are the first JHipster sponsors, and we have a booth at the conference, so don't hesitate to come to us. But now let's start talking a bit about monitoring microservices. So first, it's really hard. But why is it hard? Because you are going to meet so many problems that are just that just don't exist in a monolithic architecture. The first problem is this is a distributed system, so it's much more complex to observe, to figure out what it is going to do in production. Then the first problem you will encounter is the log files. They are dispersed. Every microservices has its log files, and moreover, every microservices exists in several instances, and you will have to find a way to centralize these logs. When you have a bug, when you have a problem, it's really hard to locate which microservice caused the problem. And then it's also hard to follow the chain of requests when you start having dozens of microservices, which is the path that your request's following through your architecture. Sometimes you don't know. Finally, when you have slowness, when you have something slow, it's hard to study latency. So facing all those problems comes something to the rescue. Those are the 3 ways of observability. So you might have heard about this before. This is really in the monitoring literature. They are talking about this all the time. Those are these 3 dimensions that we can, those 3 kinds of events that we can capture about our applications, and then which we can use to observe the state of our systems. So logs, I think you're most familiar with. Those are simply some events that are output from your systems. Metrics, which are also events, but this time they are about a numerical value. So they show a number rather than just showing some information. And finally, traces, which are the chain of calls that your request is that a request goes through in a microservice architecture. So those 3 ways, those 3 dimensions, they are actually part of one whole. You see, they are not distinct things. For example, a log could contain for example, an HTTP server log could include the response time of your request. So this would be actually a log about a metric. And similarly, you can have a log which is printing the tracing ID, which is about tracing distributed trace. So this would be also trace information inside a log. So you see the 3 are interconnected and overlap. So this is why you want to have monitoring tools that will allow you to exploit those three dimensions of observability in your application. And that's where I introduced the JHipster Console, which is a monitoring solution which is based fully on open source projects like the ALK stack from Elastic, Zipkin community project, and it's just putting them all together and integrating them to connect them to automate to make a JHipster microservice or monolith or any kind of JHipster app automatically connect to such a monitoring system. So in the JHipster console, we set up an extended ELK stack. So I will not just go through Elasticsearch, Logstash, Kibana. I'm sure many of you are already familiar with the acronym. But the important thing is that we set up everything in Docker, so it's easy to get ready, to get started. Then in JHipster, we have some code that allows you to report all those three things, logs, trace, metrics, and traces, to this console. And the way we do it is for logs and metrics, we throw them in the logs using an appender for logback. Logback is the logging system for Spring Boot. And finally, traces, we rely on a library from Spring Cloud, which is called Spring Cloud Sleuth, and which lets you forward your tracing information. So basically, it looks like this. So this is a pretty standard JHipster architecture. So you have a gateway, possibly in many instances of the gateway. You have also a number of microservices, and every one of them is going to report monitoring information to both Logstash for log ingestion and the Zipkin server. And for both of those servers, we use Elasticsearch as the storage. I've also mentioned the JHipster registry, which is a UI for the service registry we provide, which is based on Netflix Eureka, and which I also consider to be part of the monitoring infrastructure. So enough about the theory. Let's begin with the demo. So I have set up a sample microservice project using JHipster which looks like this. So I have basically three JHipster applications: one store, which is the gateway, and two microservices, a CRM and accountancy. One is using MongoDB and the other MySQL. Oh no, Postgres. So this is actually the demo that that you are going to develop if you come to our workshop on Wednesday. And this is exactly the same demo I do today. Then with JHipster, you also have a generator for Docker Compose. So you could generate a Docker Compose file which contains everything in your stack, and just boot it up in one shot. So basically, I will not answer the question live because it takes too much time. But just I've already done it. You can see I have this microservice accountancy with its associated MongoDB database, the CRM microservice with the associated Postgres database. This CRM is actually also using Elasticsearch for search, but it's just a detail. And finally, the gateway, which is the store. So let me go to my app. So this looks like this. So basically, you have a standard JHipster app, but it is split out in two microservices and the front end on the gateway. So the gateway is actually doing simple stuff, just routing, for example, every request to CRM on the /CRM route, and the same for accountancy. And you can see it is also load balancing between the two available instances for both of those microservices. So if we try a sample request, interesting. So here it is having a timeout. I don't know why. I will just try to create one data. Okay. So I'm just checking here that all my stack is up and running. So according to Docker, it is. So you have all your all the services that are up. Just one container that is down is just because it was just for importing the dashboards for Kibana. So it's working now. So maybe just something happened. I don't know. So basically, now that we have our applications running, we want to monitor it. So the first thing you can do in the JHipster microservice architecture is look at the registry, which is simply a UI that we have developed using JHipster, of course. That is just showing you nicer things over the usual cursor. So now we can see all the microservices that are involved in our application. You can also see them there, associated with some instance metadata. And what we are going to see now is how we can observe this application. So I'm going to Kibana, and I'm going to look at some logs that are coming in my server. So yeah, I see that many logs have arrived. To have a bit more logs, I will run some int e2e tests. Those come with JHipster, and they allow me to. So you see, it's running automatically some front-end tests. So this should cause quite a bit of log to come into my system. So here I can see. So for example, I have my logs coming up. Here, for example, I open one log. I see many. So this corresponds to one event in Elasticsearch, but which is also a log. And for example, I would want to see this information, the logger name and the message. And there I see I can already build some kind of dashboards. I would be able to search through it. So for example, I wrote invoice. Nothing? Strange. Oh, see? So here I can find some logs that we're talking about invoices. I could filter by level. Yes, here. So for example, I could filter only error logs or warn logs. But this you can do without anything more than just having your logs shipped to Elasticsearch and Kibana. What we provide in JHipster is some dashboards to get you started quickly. So for example, here we have some log dashboards, and we could restrict it to errors. So I have not had any errors in the last 4 hours. Maybe if I go back, yeah. So if I go back there, I can see my logs, and everything is interactive in Kibana. So you just click around, and it will add some query filters. So like you see there, it added some filters on level error, app name accountancy, query error. And then I can have a look through my logs, and I see internal server errors. Okay, so we've seen we can explore our logs using Kibana, but I'm sure many of you have already used this. But let's talk now about the second way of observability, which is metrics. So how do we ship metrics to this monitoring system? Actually, it's exactly the same as logs. We basically configured Logstash to inject metrics events to just another index of Elasticsearch. So basically, if I switch index here, I can have my metrics. And you see, for example, here I have a metrics which is related to this method, the get account. So here I will just add this column, and I will add also the mean rate. And here you see we can see our metrics over time. However, something that we must be careful is that there are actually oh no, this is a metric about the JHipster registry. That's not what I wanted. So maybe to have some logs which are more fresh, I will run a Gatling test. I will run a Gatling test to create some data, some metrics data. Obviously, we should see numbers going up over time. So I'm simply running a Gatling test, which was generated by JHipster on one entity, which is the invoice, which corresponds to the invoice page. So this corresponds actually to this page. Yes, with this this formula to just create invoices, and also the way to view it, to edit it, etc. So now that you see I have started my my Gatling test, my performance test, which is increasingly adding more users and see if my system can survive it. So I will be able to graph a sample metric, for example, the number of requests per second. So for this, I have a little note. What I need to do? Oh yes, I have to actually filter on this. So basically, I go back to this, the search view, and yeah. So I search this metrics. Here I will just filter on this. Yeah. So once you have added a filter in Elasticsearch, the very useful feature is to use the little pin. This will actually persist this filter on all the screens. So for example, if I go to create a sample visualization of this, I could create a line chart. So on the metrics index. And here I'm actually starting to create a graph. But what happened? And actually, what you don't see is that there is a very, very small point here. And the way it works is because Kibana and the ELK stack, it works by aggregation. Basically, it's always aggregating something. And what we have asked it to do is simply to count the number of events in the time period. Here we are on the last 15 minutes. And we have just asked it to count. But that's not what we want. What we would want is some kind of display. So again, I have to say which kind of aggregations do I need, but on this field, the metric mean rate. Great. So now I have the average of averages of average. So it is displaying something, but it's still not a graph. So how do I display this this line graph? You would just have to split on to use a bucket aggregation, but then it will be on the x-axis. And for example, I will use simple date bucket, and here I have. I'm starting to have my my graph. But finally, it's not over yet, because actually this shows the graph, the average of this value. But it is I actually have two microservices which are producing this metrics, so I will have to add a sub-bucket again and split this series on a term. And actually, you can filter on any term, which is any metadata associated on your event. And here I will choose the instance name. Yeah, and you see, by doing that, I'm actually showing you different the different values of the metric on the two microservices, so the two instances of the same microservices. So this is a bit hard to get around the first time you're doing it. So we have provided a few dashboards that will help you with this process. So you could just go to, for example, the request dashboard, where we do this about the request rate of a JHipster microservice, and you could just go to edit visualization, and there you have a sample of how we do it. So for example, here is the request, here is the filter, and you see we are doing an average there and splitting on time and on instance name. So so that's it. Really, in 5 minutes, what I can show you how you can analyze metrics with this stack, with this monitoring tool. The last part I want to talk about, obviously, is the third way of observability, which are traces. So, same as both of them, tracing data is available in Elasticsearch. So I could just go in this view to have a look at those events. So I will just open a random event. And here I see, this is showing me what it calls a span. A span is basically just a request, just the unit of a request in your system. So this microservices is calling this microservices. This is a span from the point of view of the microservices. And the chain of span corresponds to your trace. And it is identified by the trace ID. And this is the ID that is propagated through the trace. So here we can see it's really a simple request, which is a delete on this invoice. What we can do is click on this this link, and it's actually linking to another tool, which is the Zipkin UI, which comes with the Zipkin server, and that we have integrated with Kibana. And then here you can see a graph of which shows the details of the request. So here we can see the request first passed through the store, which is the gateway, and it was actually just proxied through to the accountancy microservice. So here we see that it took apparently 10 seconds, a bit long, I think, and this took 7 seconds. Maybe my PC was, my Mac, I mean, it was maybe blocked for some time because this is really strange. 10 seconds for just a simple request. But anyway, here we can see the full details, the precise time where everything happened, and if there was if there were an error, you would see this in red instead of blue. But what's even better is that from this view you can actually go back to Kibana and actually inspect the actual logs that were associated with this request. So here, for example, we can see, so I have added a lot of debug logs so you can see better, but this is showing you that the request first comes to the dispatcher servlet on the store, then was forwarded to the accountancy service, and then it looked for the handler, and it's successfully completed. What I want to show you as well is for a sample of a request that did not go well. So I have prepared one before the presentation. So look at this. So when it's in error, you actually get the request in red. And from this, we can see that we got a 500 error on this get request. But what you can't see with Zipkin is actually the associated logs. So what you could do if you had a simple, if you didn't have the integration between the two, we could just copy this ID and just go back to Kibana, go in your logs, and try to find it by hand. And obviously, and this is not working because it's only on the last 15 minutes. So, and then you would be able to find, but this is really cumbersome. And when you have monitoring tools that are well integrated together and they can allow you to navigate, it will be much easier to debug, to actually debug what's happening in production. So that's all for the demo. About the JHipster Console, this is an open source project on GitHub that we developed as part of the JHipster platform. And we provide Docker Compose files to boot up. We also provide Kubernetes YAML files to let you deploy it to Kubernetes. But we would like to expand more. So for example, now in JHipster, we are using drop wizard metrics to instrument code and produce metrics. We are in progress of migrating to Micrometer, which is integrated in Spring Boot. We also don't have yet a fully grown story on alerting. We are using an open source tool called Elastalert But then this is very specific on your use case, so we don't know yet what to configure for you. And finally, we would like to support Prometheus as well and Grafana for some other metrics use case. So thank you so much for listening to me, and enjoy the rest of the conference. Thank you.